In Malaysia, electricity is supplied as 240-volt AC at 50 Hz, which is efficient for transmission over long distance. The conversion from AC to DC happens in power adapters or chargers using a rectifier circuit. First, a transformer lowers the high AC voltage to a suitable level. Then, diode in the rectifier converts the AC to pulse settings DC, which is moved by a capacitor and regulated for stability. This process ensures device receives safe and consistent power.
For the calculation part, the output voltage of LM317 and LM337 is equal to 12 volt and negative 12 volt. Let's say the resistor 1 is equal to 220 ohm when Vout is equal to 12 volt. We calculate that a 2K ohm potentiometer is used for R2 to allow the output to be adjustable. Next, the IDC is calculated by using the formula above, and the IDC is equal to 5.405 milliampere. A transformer steps down the AC voltage to 12 VRMS and the peak voltage is calculated as 16.97 volt. In a full-wave rectifier, two diodes are forward biased during each half cycle, causing a voltage drop of 0.7 volt per diode. This results in a total drop of 1.4 volt, leaving the rectified peak voltage as 15.57 volt. Besides that, to maintain a steady 12 volt output, the DC input voltage needs to be at least 15 volts. This is calculated by using the formula where V peak is 15.57 volt and the ripple voltage is 0.57 volt. The ripple frequency is 100 Hz as the full wave rectifier doubles the AC frequency. Next, this is the simulations of the circuit. As we can see, the rectification process is performed by a full wave rectifier using 4 diodes arranged in a bridge configurations and which convert the AC voltage into pulse setting DC. The filter capacitor then smooths the pulse setting DC by reducing ripples, resulting in a more stable DC voltage. Then the LM317 adjustable voltage regulator maintains a constant 12 volt DC voltage output with resistor R1 and R2 setting the desired voltage level. Besides that, the capacitors are used to filter out noise and further stabilize the voltage. Resistor R5 acts as a load indicator confirming the proper operation of the circuit. The oscilloscope visually displays the signal transformation at various points.
This is a adjustable voltage regulator designed by my group using LM317 and 337. So first, a power source of 240 VRMS at 50 Hz is connected to a step-down transformer, which steps down the voltage to 12 volts VRMS. Next, since the transformer is center tapped, the center tap is connected to ground, while the positive and negative terminals are connected to a full-wave rectifier. Next, the full-wave rectifiers are connected to two capacitors, which are rated for 50 volts with 100 microfarads. Next, they are connected to the inputs of their respective ICs. LM317 is this one, which is a positive adjustable voltage regulator, and LM337 is a negative adjustable voltage regulator. The pin configuration for the LM317 is pin 1 is the reference node, pin 2 is the output node, and then pin 3 is the input node. While for LM337, pin 1 is the reference node, pin 2 is the input node, and pin 3 is the output node. Next, the output is for both regulators are connected to a 220 ohm resistor, which is then connected to the center pin of a potentiometer, 2K potentiometer. Next, the reference node of both ICs are connected to the first pin of their respective potentiometers, and then the last pin of the potentiometer is connected to ground. Next, I will talk about the positive adjustable voltage regulator. So as you can see, right now the potentiometer is set to the maximum value, so it will show a steady 12.26 volts on the multimeter, and also as you can see on the oscilloscope, it will also show a steady 12 volt voltage. So as we lower the resistance in the potentiometer, we can see the value will drop. It will continue to drop until we reach the minimum, where it will display a value of 1.181 volts. Next, I will talk about the negative adjustable voltage regulator using the LM337. So right now the potentiometer is set to the maximum value, which shows a negative 12.76 volts on the multimeter, and also on the oscilloscope it shows negative 13 volts. So as you can see, as we lower the resistance of the potentiometer, the voltage decreases. So the more we can decrease the voltage until the potentiometer is at 0 ohms, which is when it will display negative 1.220 volts, and also you can see the oscilloscope also produces a similar value.